Okay, that we are going to see an example how to calculate moment at the specified exit. In this problem, we have a pipe with 4 meter length in the x direction, 3 meter length in y direction, and 2 meter length in z direction. At the end, at point B here, we have the force 4I plus 12J plus minus 3K Newton. Okay, now we are going to find out what is the moment at each axis. It's either in x-axis direction or y-axis and z-axis. So we are going to find the ms here, my here, and mz here. Okay, so how going to find out? So by using it's either with scalar method and vector method. So let me see first the scalar method. First, we need to solve this problem. We need to define. We need to resolve. Okay, the force here into each direction s, y, and z. So this force we can resolve in s direction, force in y direction, and in z direction. Here we have Fx is equal to 4 Newton to the front. We have Fy here equal to 12 Newton to the right, and Fz here we have 3 Newton downward. Okay, and next we need to understand the perpendicular distance between this point B, here is point B, here is point A, with each axis S, Y, and Z. So here we have for 2 meter, this is the distance between this point. We have 2 meter here. Here we have 3 meter, the distance, and here is 4 meter length. Okay, this one is what we call, we can say 2 meter in Z axis, we call get dz. This 3 meter is length in y axis, we can call it dy, and here is 4 meter length in x axis, we call it dx. Okay, so how to solve the problem here? Okay, first we can directly pick up calculate the moment in x axis first. So we need to understand, okay, what is the force that can create moment around this axis, okay, mx here. If we see, we have 3 forces here. The forces that are perpendicular to x-axis is Fz and Fy, because if you see the Fs is parallel to the x-axis, so it will not create any moment. So we can have Fy that we create moment around the x-axis. So we need to multiply Fy with the perpendicular distance between the line of Fy and the x-axis. So the perpendicular distance is this dz, okay, and then we add up with the Fz with the perpendicular and times with the perpendicular distance between the action line of Fz with the ms. It is going to be this distance dy. So here we can get, okay, if we see Fy is 12 Newton, dz is 2 meter, and then we see Fy in which direction we will create moment around x-axis. So if you look here for the roots of right hand thumb, okay, in this direction is going to be positive, so this Fy we create in this direction of rotation, so it's going to be counterclockwise, is going to be positive here. And next we have Fz is 3 Newton time with the perpendicular distance here, okay, between this line of action and x-axis is going to be dy is 3 meter, and it's going to rotate in like this, okay, in clockwise or going to be a negative. So it's going to be clockwise rotation, and so it's going to be negative. And then we get the answers here going to be positive. Okay, it's going to be positive 15 Newton meter. So it's going to be rotate in this direction, counterclockwise. And then we repeat for the moment around y axis here, this y axis. Okay, in this direction like this, going to be positive. Okay, so what we have here, what the forces between three forces that will create the moment around y axis is going to be the forces in s direction and the forces in z direction. Okay, because the forces in y direction is parallel to the y axis, so it will not create any moment. Okay, if you look at fx, the forces in s component here, the perpendicular distance between this force line with the y axis going to be this line dz. Okay, dz plus the fz force. Okay, the perpendicular distance to be with the y axis going to be dx. So here we replace the values here. Fs is 4 Newton, dz is 2 meter, and if you look here, Fx going to rotate like this. Okay, against this positive rotation, so it's rotate clockwise, so it become negative. And then Fz is 3 Newton time with the perpendicular distance between Fz and y axis is 4 meter. Okay, dx 4 meter. Okay, and Fz we rotate like this. Okay, counterclockwise is going to be positive here. So we calculate this number, so we can going to be a positive 4 Newton meter. It's going to be counterclockwise. Okay, next mz. Okay, the moment around z axis. Okay, it's going to rotate like this. Like this is going to be positive values. So the forces that we create moment around z axis is going to be fx and fy, because the fz is parallel with the z axis, so it's not going to create any moment. So fs, the perpendicular between the fx here, this is the first line of fx with the z axis, so it's going to be dy, and plus the fy, what is the perpendicular distance between this fy in this direction, the action line with dz is going to be dx. So we replace the value here. Fs is 4 Newton times with the dy is 3 meter. So Fs we create the rotation in this direction. Okay, so against this arrow, so going to be negative here. And then Fy is 12 Newton times with the perpendicular distance is dx 4 meter, and it's going to rotate, okay, in this direction, okay, like this, okay, in this direction, so going to be positive. So we get here it's going to be positive 36 Newton meter in this direction. So we have determined, okay, the moment in each particular s, y, and z axis. Okay, so if we written down this result in moment, so the moment of this system going to be 15I plus 4J plus 36K, okay, Newton meter, and the magnitude of the moment is going to be square root of 15 square plus 14 square plus 36 square is going to become 39.2 Newton meter. Okay, next I'm going to show you how to solve this problem by using vector method. Okay, this scalar method And next, vector method. As we understand, okay, the moment is equal to the cross product of position vector with the force vector. Okay, if you look, okay, the question there, so we need to determine, we have the force here. The force is F equal to 4I plus 12J minus 3K Newton, and the position vector R is from the A to B. Okay, we are going to find, okay, the moment around point A, so we get the R to point B. Actually, okay, because the point B is where the force line is acting. Okay, because the F is crossing point B, so we need to find the position vector between A to B. So it's going to be S, Y, and Z. The S is 4I to the front, positive, and to the right, Y is 3 plus 3J, and it going downward here in Z axis to be 2K. So we have determined, okay, the position vector and the force vector. Okay, next, we have to set, okay, we must understand, for to determine the moment in x-axis, okay, is the cross product of the unit vector of x-axis. The unit vector of x-axis is I, okay, cross product with the M, okay, or I cross product with RAB cross product F. Okay, so we get, it's going to be a determinant of I is 1 here, J and K element is 0, okay, and then we replace the R value 4, 3, minus 2, and the F magnitude is 4, 12, and minus 3. Okay, so we determine this determinant, and we get, okay, in I element we have 1, and then 3 times minus 3 minus with minus 2 times with 12, okay, and the magnitude is 1, and then for Y component is 0, minus 0, for Z component is 0, and then we solve the calculation, we get the value is 15 Newton meter. Okay, similar to for My also is going to be J dot product RAB cross product vector F. So it's going to be the determinant of 0, because the I component is 0. Then I get J here is going 1 and K is 0. Then we replace the magnitude of position vector 4, 3, minus 2, and the force vector is 4, 12, minus 3. So we can get the value here. For I component is going to be 0. And then for J component, we have 1 for the J component, and then 4 times negative 3 minus with minus 2 times 4, okay, and plus 0. So we solve the calculation, we get it's going to be 4 Newton meter. And for MZ also is going to be K product the unit vector in Z direction, dot product with RAB cross product F. So we get the determinant of K for I element 0, J element 0, and K element is 1. Then we replace the magnitude of the position vector 4, 3, and minus 2, and the magnitude of the force is 4, 12, and minus 3. Okay, we get here, so we get the I component is 0, J component minus J component is 0, and plus the K component, we have 1 of the magnitude, and times with the 4, times 12 minus with the 3 times 4. So we get here going to be 36 Newton meter. So we have determined the result by the vector method. If you look at the result here, compared with the result that we have calculated before by using the scalar method, okay, we get